Thermodynamics is the study of heat transfer and the relationship between heat and work. And the first law of thermodynamics, because all of these theories, sets of theories, have these wonderful postulates. But the first law is that energy is neither created or destroyed. So that means that the total energy of the universe is a constant, which is an interesting statement if you think about it, because that means that the universe as a system, there's no energy being put into the universe or taken out of the universe. That means that all the energy that's available for doing any work or transferring any heat is already here. The only thing that changes is where that energy is and in what form. So a system can lose energy, but if it does that, it's got to be gained by the surroundings. Or it can gain energy, but if it does that, it's got to be gained from the surroundings. And so the surroundings are the only place that a system can lose or gain energy, and you can never, ever create energy with a system. You can only transfer energy or change the form of that energy. So if we think about some of the implications of the first law of thermodynamics, these implications are actually rather profound. But one of the problems with energies for any system is that we have limitations on what we can actually measure. And so we often can't measure the internal energy of a system. We can often measure the kinetic energy, but remember that the internal energy is the sum of the kinetic energy and the potential energies of the system. So the potential energies are often difficult, if not impossible, to determine. What is actually fairly easy to determine in various ways is actually the change in energy whenever a system undergoes some sort of change, whether it be a chemical change or a physical change, when the system is either heated or does some sort of work. And of course, by definition, when we see a change in internal energy, we always define it this way: the initial energy minus the final energy. And so if the initial energy is higher than the final energy, that would give this delta E a positive sign. This indicates that some amount of energy was transferred from the surroundings into our system. If the initial energy is lower than the final energy, then that would mean that we have some amount of energy that's transferred from the surroundings, from our system into our surroundings. So if we think about this from with a couple of diagrams down here, if you consider this, we have an initial energy here. Notice energy is on the y-axis. If we have an initial energy here and then a final energy here, that means that energy has to have been lost to the surroundings. Versus if we have a initial energy that's down here and the final energy is higher, that means energy must have been gained from the surroundings. So energy can only be lost or gained from surroundings. You can't create any energy. So here are some conventions that you'll need to know for this chapter. So whenever we're talking about energy, there are two types of energy. The ways energy can be transferred, and that is by heat or work. Okay, so the total change in energy has got to be the sum of the heat and work done either on the system or by the system. Okay, so for heat we use Q. This is the heat. If Q is positive, that means that the system gained heat, would increase in temperature and gained heat. If W is positive, that means that there was work done on the system. If the delta E for the change in energy for the system is positive, that means that there was a net gain of energy from the surroundings to the system. If you have opposite signs, if you have a negative sign here for the heat, for Q, that means that the system lost heat to the surroundings. If you have a negative value for the work done by the system, that means that the system was doing work on the surroundings. And if you have a negative delta E, that means there was a net loss of energy by the system on the surroundings. So there are two types of reactions or exchanges that can happen for chemical systems. In general, chemical processes, they don't do any work. At least for most of the processes that we'll be talking about uh, for the next few, well, for this entire chapter, pretty much. Um, but the one type of energy that is often exchanged is heat energy. And so, because of that, we're going to define or give two different terms for the two possibilities. You can either have an endothermic process, then that is when heat is absorbed by the system, that is the chemical system from the surroundings, or you can have an exothermic process, and that's when heat is released by the system to the surroundings. So if heat is absorbed from the surroundings, that means our system will heat up. And if heat is released to the surroundings, that means our system will cool down. And so if you think about the terms exothermic and endothermic, exo means going out, right? Endo means coming in. So exothermic means we're releasing heat. And endothermic means we are drawing heat in or absorbing heat. These two possibilities are the only two possibilities that can occur when we are doing chemical reactions.